Q is 3, and then PT is 1, and then TQ is 4. These are given, right? This is the X.
Yeah.
My dear students, first of all, whenever you have common vertex, common vertex, I mean two triangles two triangles that have the common vertex, and if there is an angle which is common, like 90 and 90, this is 90 and 90, and if I think, for example, Q is common for what? Common for, follow me please.
QP or
Okay. Even in the exam, you can use your pencil or pen like this. So where can I say the other common one? So, but it must have the same vertex. So this vertex and 90 degrees. So this is 90 degree. I think this one. So if I write P, Q, S, similar to which one? R, Q, R, but I said P, this is opposite of, okay. R, Q,
T.
What is left?
T.
R, Q, T. Let me check what R is opposite of this. Let's say like this, if this is 90, if this is theta, I'm just saying, if this is 90, this is 90, this is theta, can I say this is alpha? Just saying an angle. One more time, 90 given, we are saying since perpendicular, theta, so 90 theta alpha, alpha plus theta plus 90 is 180. Now, by using this information, dear ladies, be careful. Since this is 90, it's given. This is theta, so 90 and theta given. To get the total 180 in this triangle, what should it be this angle? Can you tell me? What should it be? One more time. Look at this equation. So in the triangle PQS, alpha plus theta plus 90, 180. We are saying in our mind, we are choosing alpha and theta. Right now, I am telling to you, when you look at QTR, this is theta. This is 90. So theta here, 90 here. To get the sum of the interiors of any triangle 180, what should it be this angle? When I pair this, it is directly seen that it must be also alpha. Yes or no?
Yes.
So in the first triangle, I have three angles, and other triangles are similar. We call this angle similarity theorem. Angle similarity theorem. Is this okay?
Yes.
We know this. What is the rule? Rule says this. For the similar triangles, corresponding sides are proportional. Let me write. Corresponding sides are proportional. What does it mean? It means this. For example, if I use this triangle, you may start with the QPS also, no problem. Opposite of alpha is 4. In the other triangle, opposite of alpha, I have 3. Am I right? Check it by yourself.
Yeah.
So in this triangle, which I started, opposite of 90 degrees, it's 3 plus x. So in the other triangle, where this is 90 here, opposite of 90 degrees is 5. Am I clear?
Yeah.
I may continue, but no need, since my aim is to find x, so cross product, it's finished. So cross product, 20, 9 plus 3x, 11, 3x, x is 11 over 3, part B, alternative B. Am I clear?
Yes, sir, but I didn't get the, could you please re-explain it again because I didn't get the how we found
One more
formula.
time, no problem from the beginning, no
Thank
problem. So the thing is, we should find similar triangles. Similar triangles. So when I look at these triangles, let us look at together first of all. This is 90 degrees given. So
Yes.
can I say this is also 90 degrees directly?
Yes, because it's
Let me
perpendicular.
call this as any letter, whatever you want. Let me call alpha, beta, gamma, whatever. Alpha, let me say here right now. I am changing. This is alpha. Now my question, in this triangle, if this is 90, if this is alpha, this is, I can call 90 minus alpha.
Mhm.
Can I say 90 minus alpha? Why? 90 minus alpha plus 90 will be 180. Or I don't want to work with this. Let me call this is one letter, which is, let's say, beta. So I am calling this angle is beta. It is totally up to me giving the different name or theta, beta, whatever you want. This is now angle beta. Where? Here. Any question?
No, sir.
So can I say alpha plus beta plus 90 degrees is equal to 180 degrees? What do you think?
Yes.
Very good. Now I want you to check this triangle. When you check this triangle, 90 degrees, alpha
Yes.
plus angle P is 180 degrees. Is it true?
Yes.
So what could it be P? This is 90, 90. This is alpha, alpha. Since right side 180, 180, that means that it is clear that this must be also beta. I mean, this is right now beta. It is okay?
Yeah.
How did I decide this, Mariam? Why? I mean, I said, look at this. The thing is, practical way is this. Always, when you have common vertex somewhere and common angles. So this is 90, this is 90. Two angles common and one vertex common. When the vertex is common, isn't it the angle is also common? I mean, if they use the same vertex, so they have the same angle. That means two angles common. To create a triangle, I need three angles. The two of them is same means the third one automatically is same.
Yes. Yes.
And in geometry, we have angle, angle. Actually, angle, angle, angle also you can call, but normally we say angle, angle. Why the other one is automatically is same. Angle, angle, similarity theorem. What does it mean, angle, angle, similarity theorem? Do you know this theorem? Let me explain, or you know this?
Can you explain?
No, sir.
No means you know or you don't know?
No, we don't know, sir.
You don't know. Let me explain this. It's so simple. Let me explain. This is triangle, let's say A, B, C. This is, let's say, angle A, angle B, angle C. This is side A, this is side B, this is side C. Now I am taking this one, just, you know, like using a tablet, just do like this.
Okay.
When you do this one, let's say, so this triangle will be DEF, for example. So the angle will change or not? What do you think? If this angle this, it will be same. If this is this, if this is this angle, this will be same. Yes or no? What do you think?
Yeah.
Since we are not changing the angle, we are just zooming, okay? So we will have same thing. Imagine this one, let me explain. Imagine this one. When you use the slope, for example, or when you use the parallel lines, so this angle is equal to this angle, or even this angle, even this angle. If they are parallel to each other, they are all equal to each other, right? Similar thing you may regard, you may think in your mind. Now, since two triangles have three common angles, we have one theorem which is called angle similarity theorem. Similarity theorem. It says this one: opposite of same angles, the sides are proportional, or let's say corresponding sides are proportional. What is proportion? Means ratio, A over B, 1 over 2, 2 over 5. Proportional. What does it mean? For example, you may say 30, 60, 90, 30, 60, 90, 40, 50, whatever, 40, 50, whatever. I mean, it must have same angle. So in the first triangle and in the second triangle, let's say, in the first triangle, opposite of these angle, which is 30, for example, if I have side length B, this is divided by, in the second triangle, opposite of same angle, which is E. And then in the first triangle, opposite of this one, if I have A, opposite of same angle in the second, D, is equal similarly C over F. And this is common ratio. Even you can call this as number K. K is a real number. Okay?
Okay.
So in our question, for the similarity, be careful. We have angle similarity. This is one of them. We have side angle side similarity also, which means two sides like 3, 10, 30 degrees, one triangle. And let's say other triangle, you have 30 degrees and 310 you have. These are also similar. Or even not 310, 6 and 20. What does it mean? 3 over 6, 1 over 2. 10 over 10, 1 over 2. So they have the same ratio. Angle, side angle, and also side. It is exactly like you are checking A over B, C over D, E over F. If they are all equal, I mean 1 over 2, 1 over 2, and 1 over 2, these sides, A over D, C over F, B over E, you say that these are similar. So corresponding angles must be congruent. Opposite of 3, you must have same angle. Opposite of 4, you must have same angle. Something like this. So when I turn back my question, you understand right now why they are similar?
Yes, but does this also refer to CPCTC, the corresponding parts of congruent triangles? It was something about when the corresponding parts of a similar triangles, they're congruent as well. So if we're talking about
not congruent, congruent means almost same. Similar means the scale is different.
Okay.
Congruent means copy paste. Yeah. But similar means copy paste, but you are just how can I say, scaling. You are getting enlarging or getting smaller the figure. Now, one more time, angle similarity I have. Why? In this triangle, alpha, beta 90. In the other triangle, alpha, beta 90. So they have all congruent angles. Same angles. For that reason, they are similar. So I am saying that, for example, let me take this triangle first. In this triangle, so it was 3, I think, 3, 1, 4, and X. It was like this or not? Let's check. PQ, PT, yeah, that's it. So I am telling to you right now, opposite of alpha, there is something I don't want to use. I have to use Pythagorean theorem. I don't need. Opposite of beta. What is opposite of beta? 4. Now, pardon, it didn't write. Let me write again. Opposite of beta 4. Now in the other triangle, which is this green part, which is this part. What is opposite of beta? You have beta is here, right? So what is opposite of beta? Which side you have? The side length 3 you have, isn't it?
Yeah.
So in the small triangle again, or the first triangle, how do you start the question? Opposite of 90 degrees, opposite of 90, you have 3 plus x.
Yes.
Now, in the green triangle, opposite of 90 degrees. So what do you have opposite of 90 degrees? All this side, which is 5.
5, yeah.
And then cross product, x is 11 over 3. Okay? Is it
Yes,
okay?
now I understood. Thank you so much, sir.
Welcome.